This video is dedicated to learning how to calculate a two-mean hypothesis test, but the samples are dependent. In a previous video, we discussed how to handle the situation if you have independent samples. Now we're going to discuss what happens if the samples are dependent. Okay, so how do we perform a hypothesis test for dependent, or sometimes it's referred to as paired data? So if you remember in the independent samples video, I said a dependent sample is the scenario where you have, dependent data. And dependent data means that the data is somehow paired or linked together. So what that means is that we really don't have two separate data sets. What we really have is just one data set. We just recorded the data at two different points in time. So because of that, instead of looking at both data sets, what we're going to instead look at are the differences between the two data sets. So a dependent hypothesis test on the means is actually a test on the difference. And so what we're going to do is, as they say here, we're going to perform a t-test for the difference between the means of the paired data. Okay, so we're actually going to perform just a regular t-test on the difference between the data. All right. But as always, there have to be conditions met before we can perform any type of hypothesis test. Okay. Since we're talking about means, we're talking about we must have the central limit theorem satisfied, meaning we either need our sample size to be greater than or equal to 30, or we need the population to be normally distributed. All right. So if those requirements are satisfied, then a paired sample t-test is going to be used to calculate the p-value, which we will need. But the key here is that the hypotheses are going to be a little different than what we're used to. When it comes to a paired data or dependent data hypothesis test, what we're actually going to do is, like I said, we're going to look at the differences. Okay. In fact, we're going to look at the mean of those differences between the two data sets. So our mu d, so mu d stands for the mean of the differences, okay? Our alternative hypothesis will be either the differences will be something negative, which indicates we are less than 0, or, okay, so these are all the possible alternative hypotheses, or the differences will be greater than 0, meaning the difference is positive, or we could test potentially, does the difference, is it not equal to 0, or is it different from 0? Okay, the way that the differences are defined is depending on really on your problem. Okay, so let's try a problem really quickly. Okay, so a researcher wants to show that more Washingtonians, I guess people living in the state of Washington, actually prefer the city of Seattle to Spokane. Okay, so she does this by testing a new random group of 40 residents every month. The paired data of Spokane residents who prefer Spokane or Seattle is given below. So she interviewed a bunch of Washingtonians and asked them, do you like Spokane or Seattle below? Assume that both populations are normally distributed. Okay, because as you kind of peek at this, you see that there's some sample sizes that are smaller than 30. Anyways, use a calculator to test whether the mean difference preference of city is greater than 0. Okay, compute that use alpha is 0.05 and compute the differences as Seattle minus Spokane. Okay, so what that means is that our mu d, okay, is going to be the mean of the differences between Seattle minus Spokane. Okay, that's because they told us that's how we're going to define our difference. And so if we're trying to, I guess, test if more people like Seattle than Spokane, then that means that we need this difference to be something positive. An easy way to check this is just plug in some numbers that kind of follows what they're claiming. If I'm saying that Seattle is more than Spokane, that means that if I say Seattle is 30, and I'm saying that Seattle is more than Spokane, that means that Spokane has to be a number that's smaller than 30. I'm just making up a number 28, let's say. Okay? I'm just making up these numbers that follow the scenario that we're in. So if Seattle is more than Spokane, what that means is that this difference is a positive 2. Keyword is positive. So this 2 is greater than 0. So whenever we're trying to test if Seattle is more than Spokane, we're actually testing, is this mu d, this difference, is it, the mean of the differences, is it greater than 0? On the other hand, if you're trying to test if people like Spokane more, then if your difference is still Seattle minus Spokane, now you're saying, okay, Spokane's a bigger number. All right, so let's try it. Let's say Seattle was 30, and we're claiming that now Spokane has more people that prefer it. Well, let's say 35 people like Spokane. That's the case where Spokane has a larger number. In that case, that difference is a -5. Okay, so it all depends on what's your hypothesis. It depends on, first of all, how you define your difference, and who are you trying to measure is more than the other. Okay, so I'm going to erase this, not to confuse anybody. So our case, we're trying to measure, is Seattle more than Spokane? That is why our HA is that mu D is greater than 0. Otherwise, our H null is mu naught is equal to 0. Okay. All right, so now, how do we actually perform this this hypothesis test? So this is what you do. Whoa. All right, what you're going to do is you first of all are going to take your paired data set. And what that means is that you're going to take all of Seattle data set, you're going to plug that into L1. You're going to plug the Spokane data set into another list in your calculator, L2. And it's very important that you make sure that your data is paired, meaning the first entry for your L1 is 24. The second entry needs to be 16. They have to match up exactly. Okay, so let's do exactly that. Let's pull up our calculator. Stat, edit. Okay, I've written down the values. I'm just going to go ahead and put them in. Let's see, so L1 is 24. 18. Let's see, 23. 25, 32, 17, 19. What else? A few more. I think it's a 34, 20, 19. I believe we should have 12 values because she did it every month for a year. 28, 28, and 19. Okay, that is our L1. Let's go on over to L2 and make sure we line up the same values for L2 here, or the correct values for L2. So that was 16 was the first. 22, 17, 15, 8, 23. Uh-oh, go back up. This should be a 23, 3, 21. What do we have next? 6, 20, 21, 12, and 11. All right. So we have our data set in there, and hopefully they're all matching up. So here is the deal. So we are going to go back to my work. Remember, our hypothesis is based off the difference of Seattle minus Spokane. So what that means is right now, we need to actually calculate some differences. So if I go back to my calculator, what that means is I need to take my L1, because that's Seattle, minus Spokane. So I need 19 minus 21, 34 minus 6, so on and so forth. So you're thinking, I don't want to do all of those by hand or one by one. Well, the cool trick is that we can actually calculate these differences automatically. This is how you do it. Go over to the L3 column and go up to the top where the L3 is highlighted. So you're all the way up to the top. And you know you're at the top where it says L3 equals. Well, L3 is going to equal my L1 list minus my L2. So if I'm up at the very top, if I hit second 1, that's how you type L1, and subtract away second 2, hit enter, and look, it calculated all of those differences for us automatically. Okay, one more time. I went up to the top, make sure you're at the very top, and we did L1 minus L2. All right, now that we've created our L3, what you do, because now we've collapsed the two data sets really into one data set. And now what you do is you're going to perform a t-test on L3. All right, you always do a t-test for the dependent data set. A t-test on that L3. What I mean by that is we're going to go to Stat, Test menu. Number 2 is the t-test. Okay. For the input, this go around, we have actually the data set. So we're going to go to Data. The mu null, the mu naught, whatever you want to call it, that is 0 because that is from our hypothesis. Remember, our hypothesis is that our claim is that mu d is greater than 0. Our list is what list do you want to perform the t-test on? Well, I want to perform it on the differences. So what that means is it's not on L1 or L2, but it's actually on L3. How do I type L3? Second 3. Frequency is always 1. You're never going to change that for this class. And at the bottom, as always, is asking for what type of test should we perform. We need to perform a right tail test. So we are going to select the right tail option. All right. We go down to calculate. And with any hypothesis test, it's the same process, man. You calculate a test statistic. I won't bore you with the formula, but that t-score is our test statistic. And then what we're saying is the area to the right, or the probability that we're to the right of that t-score, is the p-value, which in our case is a 0.022. So our p-value ended up being a 0.022. And let's make a decision. So to do that, we take our 0.022, compare it to alpha, which I believe was a 0.05. Yes, it was. 22 is less than 50. The p-value is less than alpha, therefore we should reject the null hypothesis. Which means what? It means that there is enough evidence to support the claim. And what was the claim? The claim was that, remember, mu d is greater than 0. Well, what does that mean? That means that Seattle minus Spokane is greater than 0. That means that more people prefer Seattle. So there is enough evidence for us to say, based off this, the evidence collected, that there is a preference of people wanting to live in Seattle more than Spokane. All right, see you all in the next video.